So, you too have passed by to warm yourself at the Bonfire of Dreams. It's funny. You can almost see everyone's hopes and dreams flicker in the flames. For men like you and I, our light is not seen amongst them. For all we know is the sword and nothing else. The mercenary who raised me only taught me one thing: how to survive. But living only to fight for the next day is not truly living. Without dreams, we are hollow souls. You know, Griffith told me you have a dream. He told me you want to study to become an engineer. I think that's great. I truly do. You should believe in your dream. One day your light will burn even brighter than Griffith's. Lucky for you, I actually know a few things about electrical engineering. Here, let's chat about electrical faults for a while. In an electric power system, a fault or fault current is any abnormal electric current. For example, a short circuit is a fault in which a live wire touches a neutral or ground wire. An open circuit fault occurs if a circuit is interrupted by a failure of a current-carrying wire, or a blown fuse or circuit breaker. In three-phase systems, a fault may involve one or more phases and ground, or may occur only between phases. In a ground fault, current flows into the earth. The possible short-circuit current of a predictable fault can be calculated from most situations. In power systems, protective devices can detect fault conditions and operate circuit breakers and other devices to limit the loss of service due to a failure. In a polyphase system, a fault may affect all phases equally, which is a symmetric fault. If only some phases are affected, the resulting asymmetric fault becomes more complicated to analyze. The analysis of these types of faults is often simplified by using methods like symmetrical components. A transient fault is a fault that is no longer present if power is disconnected for a short time and then restored. Some transient faults only temporarily affect a device's dielectric properties, which are restored after a short time. Many faults in overhead power lines are transient in nature. When a fault occurs, equipment used for power system protection operate to isolate the area of the fault. A transient fault will then clear, and the power line can be returned to service. Typical examples of transient faults include contact with trees, animals, lightning, or other conductors. Transmission and distribution systems use an automatic reclose function, which is commonly used on overhead lines to attempt to restore power in the event of a transient fault. This functionality is not as common on underground systems, as faults there are typically of a persistent nature. Transient faults may still cause damage at the site of the original fault, or even elsewhere in the network, as fault current is generated. It's funny. All this talk about faults reminds me of the faults I've internalized due to childhood trauma. I shouldn't dwell on these thoughts. We need to move past the pain, even if that pain is all we know. Sorry to get distracted. Let's get back to talking about engineering again. A persistent fault is present regardless of power being applied. Faults in underground power cables are most often persistent due to mechanical damage to the cable, but are sometimes transient in nature due to lightning. There are two types of faults, symmetric and asymmetric. There are three types of asymmetric faults: line-to-line fault, line-to-ground fault, and double line-to-ground fault. A line-to-line fault is a short circuit between lines, caused by ionization of air, or when lines come into physical contact, for example due to a broken insulator. In transmission line faults, 10% are asymmetric line-to-line faults. A line-to-ground fault is a short circuit between one line and ground, very often caused by physical contact, for example due to lightning or other storm damage. In transmission line faults, roughly 70% are asymmetric line-to-ground faults. A double line-to-ground fault is when two lines come into contact with the ground and each other, also commonly due to storm damage. In transmission line faults, roughly 15% to 20%, are asymmetric double line to ground. A symmetric or balanced fault affects each of the phases equally. In transmission line faults, roughly 5% are symmetric. These faults are rare compared to asymmetric faults. Two kinds of symmetric fault are line to line to line and line to line to line to ground. Symmetric faults account for 2 to 5% of all system faults. However, they can cause very severe damage to equipment, even though the system remains balanced. A ground fault is any failure that allows unintended connection of power circuit conductors with the earth. Such faults may energize the housings of equipment at a dangerous voltage. Some power distribution systems may be designed to tolerate these faults. Wiring codes may require an insulation monitoring device to give an alarm in such a case, so the cause of the ground fault can be identified and remedied. If a second ground fault develops in such a system, it can result in overcurrent or failure of components. There's one more type of fault I want to tell you about. It's called arcing. Wherever the system voltage is high enough, an electric arc may form between power system conductors and ground. Such an arc can have a relatively high impedance. I could keep going, but I think that's enough. We should really go join the others. Griffith will be returning to the campsite any moment. Hopefully my words have some meaning to you. Use what I've told you. Follow your dreams and become an engineer.